For this tutorial, we're going to continue our look at objects and classes, and I'm going to pick up where I left off in the previous tutorial. So I've already defined my fraction class, and I've already defined a test fraction class, which is for testing my fraction class. Each of them is saved in their own file. Excuse me. So the first thing we're going to do from here is now, for this lesson, we're going to look at something that are called instance methods. So you're probably familiar with the idea of methods already. So instance methods is going to pick up with something I was talking about before, which is that an object or a class, when you create an object, the first object we created was a fraction, and it was simply an assembly of fields. That's a data structure, and lots of programming languages that are not object-oriented also have this idea of data structures. Because all I'm doing is I'm gathering together the data that I think goes into a fraction. In this case, it's two integers, numerator and denominator. But really, when you get into object-oriented programming, the next step, the step where you change from a data structure to an actual object, is where you get into the idea that an object is supposed to be able to do things. Now, to do things in programming, we use methods to do things. And so what I want is, if I go back to the idea of a class is a design, or it's an idea of what a fraction is supposed to be, then we can get into some ideas of what you want a fraction to be able to do. And in particular, what do you want the fraction to be able to do that really only it can do with itself? So for example, I'm going to start off with, because my fraction has a numerator and denominator, I might want to know the overall size of that fraction. And yes, I could pull out the numerator and denominator separately, and I could divide them, take the absolute value, and get my size that way. But if I consider that to be a useful function for the object to be able to perform on itself, to be able to tell me how big it is, then it's worth considering including that as an instance method. So the first thing I'm going to point out here is, in this case, I'm going to have a return value, and my return value is going to be a double. So I'm going to create a method called size. It's not going to have any parameters, and that method is going to calculate and return the size of this fraction. And I can do that in a single line. The value I'm going to return, actually I'm not going to do it in a single line. I'm going to create a variable called answer. I'm going to say answer is equal to. Now the first thing you might try is you might say, well, that's it. It's num divided by den, return answer. Unfortunately in Java this won't work because numerator is an integer and denominator is an integer. And so if you do this, it will perform what's known as integer division. So it will actually tell you the whole number for how many times numerator fits into, how many times denominator fits into numerator. The way that I can get around that is with a cast. So I'm going to force the numerator to be a double, something with a decimal. And now when I divide that by an integer, well, I already started with a double value. And so now my division operation is a real operation, involves decimals. And so now I'll get an answer that is a decimal. But I don't care about the sign of this. So I'm actually going to take the absolute value of the whole thing and return that. Now, there's a couple of things here that I want to point out. Those of you more familiar with the language may be wondering about a couple of things that I excluded here. One of them I'm actually going to leave out for the time being. But one that didn't get put here was the word static. And if we take a look back here, public static, well, okay, I guess public is there as well, so I might as well fess up and say I didn't include public or static. I'm going to deal with the whole public part in a different lesson. I'm only going to address static right now. So static is a keyword that defines that something. Essentially, the easiest way to say it for now is to define something that is not an instance method. We're going to look at non-instance methods. They're called class methods. We'll look at those in a later tutorial. For now, we're looking at instance methods, which means I don't apply static. Now, another way of putting that into perspective for you, the word static, is each of these objects, the fraction f and the fraction g, each one of those is its own unique object. And the static keyword would mean that this method operates the same way no matter which object calls it. But we actually want size to be different depending on which object calls it. When f calls size, that's going to be the absolute value of 2/3 changed into a decimal. When g calls size, that's going to be the absolute value of 5/6 turned into a decimal. So we specifically want something that is not static. If they had a keyword for it, you would almost want this to be called something dynamic. Every time you call size, it depends on who does the calling. It depends on which instance, which object does the calling. So now that I've done that, I should be able to go over to my test program and go system.out.println, and I'm going to get the size of f. Now, the way size is not a field, it's not a variable, so I don't just end with f.size. I have to do open bracket, close bracket, and then system.out.println g.size. And when I compile all of this, missed the semicolon. When I compile everything and I run this, you'll see my result in my output window down here at the bottom. The first one is 0.666 repeated. The other one is 0.833 repeated. And those are the correct values for these fractions. If I changed this one to a -2, compiled it, and run it, I'm still going to get the same result because I asked for the absolute value. Okay, so that's an example of an instance method. It's going to be it's going to run this code differently depending on which instance, which object called it. Now there's something else I want to introduce here, and it's something that will come up in other code that I write. There is a keyword in Java called this, and it applies to object-oriented programming. And what that keyword means is it's essentially saying this instance. So whenever you use this, you're saying the object that called this method. Now, we've got such a simple setup here, there's really not a lot of ambiguity. When f called size, that's the only numerator and denominator I could have been talking about. But this seemed like a good place to introduce this idea that this keyword is a way to explicitly say that I am referring to the field, in this case it's the num field, the numerator field, of the object that called this method. I'm referring to the denominator field of the object that called the method size. Let's do one more instance method. This time I'm going to create a method called isLargerThan. And this one's a little bit more interesting because the isLargerThan method allows me to compare the current object to another object. So it's still an instance method, but now I'm actually going to give it a parameter. I'm going to pass it a fraction parameter. And I'm going to call this other, and hopefully you'll see why in a moment. I think it'll make it a little bit clearer here if I actually show it in use before we actually code it. F dot is larger than, and then I'm going to compare it to G. And I'm going to do the same thing, and I'm going to reverse it. And hopefully, if you look at this as far as a good naming convention, read this in English, F is larger than G. That is clearly a Boolean statement. That's actually going to be true or false. And the statement F is larger than G is going to have a different result than G is larger than F. because I'm reversing the order. It depends on which one of these is the calling object. So this is going to be a Boolean, is larger than, and I'm going to pass it another fraction. So how do I compare, is one fraction larger than the other one? I'm going to use the size instance method that I created. And so what am I going to return? Well, if the current object is larger than the other object, what I'm essentially saying is I want to know whether this dot size, whether the size of the current object is greater than the other object's size. And so maybe you might think that the use of this keyword is a little bit better in this case. We could have done this. We could have just said size is greater than other dot size. I find that a little ambiguous. Other dot size is pretty clear. I'm talking about the size of the other fraction. But I think this is actually quite a bit nicer to say this dot size is greater than other dot size. Now I'm not going to bother accounting for what happens if one is larger than the other. Actually, you know what? This takes care of that. If this is larger than other, it's clearly true. Otherwise, it's false, which means if they're equal, it will also be false. So that's actually good code the way it is right now. Compile that. We're error-free. Go back to my test code and run it. Okay. The fraction f is 0.666 repeated. The fraction g is 0.833 repeated. Is f larger than g? Is this first fraction larger than the second fraction? Clearly that's not the case. So the answer is false. If I reverse the order, if I ask is the second fraction larger than the first fraction, that's clearly true. And so I get an answer of true. So there you have a couple of instance methods. We've specifically not included the keyword public and the keyword static. And I've explained to you why we didn't include static. Dropping the keyword public, well, we're actually going to reintroduce public, but I don't want to bring in that keyword until I explain what your options are there and why you do it the way you do it. So that will be in a future tutorial.